Hey everybody, welcome back to the channel. Taking a break from deer hunting because the weather just sucks. It can't make up its mind if it's going to be hot or cold, and had things to do around the house, so for the next day and a half I'm free. Anyway, thought I'd make some kind of video. I've got a lot of projects to do. I've got a lot of projects that we've started and we haven't finished. But thought about we'd take a quick look at this Transoceanic, kind of figure out how to get it out of its case without tearing it up, and evaluate it, see what else is going on with it, see how the filters are and all this kind of stuff, and see if we might possibly get it running. But I ordered a set of tubes for it. Those 1U4s, I've got a couple of those, a 1S5 and a 3V4, so got them fairly good price off eBay. Two of them are Jans. One's an RCA, 3 Jans and one RCA. But thought it did real good. New old stock. Anyway, I'm going to get the camera set up here, and we'll get that Transoceanic, and I'll try to figure out how to get it apart without tearing anything up. But let me get, like I said, let me get it all set up, and we'll dive into this thing and see just what kind of shape it's in. So I'll bring you back when I'm all ready to go. Okay, bye. All right, now I got the radio on the workbench here. Got the back opened up on it. There's the operating guide and everything. We'll put it over here in a safe place. And here is a battery. Trying to be delicate with it. Get a screwdriver. And my son's working on his four-wheeler. Paper's intact, but boy, is it! It's pretty rough shape. It's an A battery. Hey, this is a battery. It says, I think it says 1.5 volts. Very delicate. I would like to save this. Put that over here out of harm's way. So looking at it, the antenna is right here, the telescoping antenna. It's connected to like a quick terminal right here. That's nice. I'm thinking that has to come out to give you room to pull the radio out. Looks like it's going to pull from the front. So let's take these two screws off right here. Can you see? Now let's get these two little nuts out right here. Parts holder. A couple of little lock washers on there that be mindful of. So the whole telescoping antenna came out as an assembly, rather intact. Move that out of the way, get that out of harm's way. Now we got the wave magnet antenna right here. It's got to come off. It looks to me like this just pries off. This just comes straight up. Try to be delicate as I can. I'm going to take these two retainers off right here. Pull this loop out of the way. There we go. Get that out of the way. Now let me have a look in here. Got the line cord that comes in right here. Excuse me. Got the line cord that comes in here. Looks like if I just plug this in, then this chassis will have to come out this way. Looks to me like. Let me look in the front, see what it looks like in the front real quick. Make sure there's nothing that I have to do or undo, whatever. Two knobs. Hoping they just pull off. They do. There's the phone connector, the dial light. I'm not sure. Not sure what actually has to go. I don't know. Let's just see. Turn the radio back around. There's a hole here and a hole back here. That looks like it's where you get access to the screws and everything. And then here's a strap that goes to the chassis right here. If you can, right here. Like that's really all it is. If I undo that screw right here, this Phillips head, there's a little strap right there. Take that loose. Just take these two nuts, these two bolts off of that. I think this thing will come out. So let me try that. Better Phillips screwdriver. Okay. Lay it on its face very carefully. Quarter-inch ain't long enough. Now it is. Get that star washer out of there. Easy way to lose something is not take it out and get it out of the way. Alright, now we'll set it back up. I'm going to attempt trying to find a safe place to grab this thing. Wiggles a little bit. Find some place easy to grab this thing. Stone frame, yeah. moving. Like there's something in here. There was a speaker jack. I wonder if it's got to come loose. There's the switch right here and the speaker jack. I wonder if that has to come loose. Let me get that speaker jack loose. Not sure. I don't think this is a smart move here either. There's probably a nut that just went somewhere. Try again. Wish I could get this out of the way. In frame? Yep. Try again. It ain't wanting to come out for some reason. So much cobweb in here. It could be that rubber that's acting as a I'll pry on it a little bit here. Yeah, I think that's up. I hope. Yeah, it was the insulating material for the speaker, I think, was holding it. That's in the way. One little peg right here. I don't know. Clear that or not. Damaging something. Didn't think that antenna had to come out, but again, I don't know. I'm going to tear up this nice radio because I don't know what the hell I'm doing. There's really nowhere to grab this thing. It wants to come out. Just wondering what have I not done. He's grabbing something that I don't know about. I'm about to rip something out of this thing that's very important. I see something going right there. And it looks like, yep, found it right here. That's what that battery is for. That was the pilot light. I gotta push it back in. That's what that battery is for, just to tell you the thing was on and see, so you could see the dial at night. That's what that switch is for, and I didn't have to pull that switch out. Let's see what happens this time. I'll have a look. Yep. We have a chassis. So, unhook you for a second. So the switch right here that I took the screws out of the front, because I didn't know any better, that is what hooked to this battery right here that we pulled out a minute ago. That battery, I didn't know what it was for, but now I do. That battery is what connects to this switch and connects to this light. So anyway, there's the inside of it. Some cobwebs here and there. It needs to be all cleaned up. But now I know. So let me get this out of the way and then we'll have a look at the chassis. Okay, so I guess for these people that's looking to me for advancers and advice or just seeing how the heck I do this stuff, on the front panel here, leave this wired on this side. Don't do anything with this switch right here. These two screws, leave them alone. The headphone jack, which is this guy, go ahead and take the nut off that's holding it. That way you can pull it out. Take the two knobs off right here. And that's all that you have to do. This nut right here for the headphones and the two knobs. That's all you got to do on the front. On the back, this little bracket right here, take the screw out of it. And there's two screws underneath the chassis, which is you access through these holes right here. They're 1/4 inch heads, and that's these guys right here. So just need a long Phillips head or an no, I'm sorry, 1/4 inch head or one with an extension. Anyway, there's that. So let me get the cabinet out of the way and bring it back. Okay, we got the cabinet out of the way, got it out of harm's way, down on the floor. Here's the radio. The voice coil looks good. I feel no problems with it. Old dad's speeder. Faceplate looks good, just all a little bit dirty, needs to be cleaned. All the band switches right here, they'll probably need a little servicing. No big deal. Tuner section right here. Little looks good. I don't really see no corrosion. Hopefully all that stuff's good. Got a few little spider webs on here and there, so we're good there. We'll just, I think I'll probably use some compressed air for that, very lightly. The chassis doesn't look too bad. Minor rust here and there, a little roach egg right there. Hopefully long time since gone. There's some more spider webs around the speaker. No big deal. Some light rust right here. Probably investigate taking this off, de-rusting it. I'll have to see just how much trouble that is and compare it to what I really want to do. Looks like the dial cord is pretty intact, so try not to mess with that too much. Just by looking at this, it has 455 kilohertz IF frequency, so that's pretty good. There's the cord. We'll test it for viability. Seems to be rather pliable. Little coil start right here. Seems to be pretty good. I might leave it alone. It doesn't feel like it's dry rotted or nothing, so it doesn't want to completely retract, but Probably got old grease in it, I don't know. The chassis is pretty good. What I thought was rust right there is just a little bit of dirt. A little bit of cleaning, this thing will probably look a lot better. So, stop you for a second and we'll take a look at the underside. Okay, here's the underside of this belly of this beast. Hang on, something important we gotta do. Gotta get some coffee out of one of my favorite mugs. This is irreplaceable. Irreplaceable cup right there. Anyway, here's the bottom side of the radio. Looks pretty good over here. No problems there. Typical Zenith capacitors. I miss my guess. It's probably a 3-lead capacitor. Maybe not. Don't know. Some of them are. Some of them ain't. Looks good, but look what we got here. Little black beauties. We got 1, 2, 3 of them little dudes. 4 back under behind that. 5, 6. Look at that one. Look at that. Probably oil filled. Yes, it is an oil filled capacitor. See that little tab right here? If y'all can see that. See that little tab on the end of that capacitor right there? Get that red wire out of the way. See that tab? Right there. This is an oil filled capacitor. And look, I don't know what exactly that is. I know this oil is escaping this capacitor. It's an 047. So this is a bad capacitor. So how many do we say? We have 1, 2, 3, 4, 5, 6 of these that's got to go automatically. Then we got 1, 2, 3 of these dudes that's got to go. And then we got an electrolytic right here that's got to go. Let's see. I believe that's probably a resistor. Here's your selenium rectifier stack right here. And here is the good old electrolytic can capacitor, like a 4-section. Yeah, 1, 2, 3, 4. Y'all know what I'm going to do to that. So, a bunch of resistors. Allen Bradley styles right here. We'll do a spot check on them. There's a little domino. Whoop, excuse me, a little domino right there. Let's see. All in all, it looks very nice, very clean. Other than just a little bit of, let's see, there's the tuning gang right here. Let me feel that rubber on there. That rubber is a little hard. May or may not, oops, sorry about that. May or may not decide to do something with that. I think it's fine for right now. So that's what we got. And let's go back to this right here, this capacitor right here, little bumblebee. This is oil filled. That little tube right there, how they fill it full of oil. That's how you know if those are oil filled. And this one's oil is escaping. As you can see, that substance move as I do this. But if you compare it to this one here, this is not an oil filled. See, it does not have a tube on the end bit. So, but I can guarantee you these caps, I will probably change them. I just don't trust them. There's some people that do, but I don't. I've seen too many of these things short and pop. Matter of fact, that piece of test equipment right there, it's an HP voltmeter. I had one pop on me and blow up. That's just how unreliable these things are. They were reliable when they were new, but they're not. This thing is not new anymore. So anyway, we got that to do. So, so that's where we're at. Start testing components. So I'll bring you back at the next juncture of this segment. Okay, got the radio up on its back, and I want to take, and just for fun, giggles, I want to take this little black beauty out, which is that looks like a 0.022 microfarad. 2, 2, and 3 zeros. That's in microfarads. So you got 3 zeros, 0.022. So that would be 22,000 picofarads, which make it 0.022 microfarads. The voltage rating, red. I gotta remember. I don't remember what that is, but this is probably a 200 volt capacitor. Anyway, I'm going to desolder this capacitor, try to get it out whole, and we'll put it on the capacitor analyzer and see what's up. Going to add fresh solder to that. There's my son and his four-wheeler. Stinking up the place. It's got a little bit of blow-by. I think he's got ring failure. It just happened all of a sudden, which is indicative of a ring failure. Usually you just put a little fresh solder on these things when they're this old, just kind of gets a little bit of the oxide off. It gives it a fresh surface for the desolder machine to do its thing. You can use solder and desolder and wick or whatever. Yes, that's much better. So I think I bumped y'all. I'm trying to do this without branding myself and mind y'all's way. There we go. On y'all's way, not too bad, huh? I wonder if I'm talking loud enough for you guys. Let me get my tools. Wasn't quite prepared for the job, was I, boys and girls? I need some glasses, y'all. I can't see nothing. There we go. Had to get my glasses on. Anyway, let's pull this capacitor out. I want to get it out intact. One thing about working on these old radios, and I'm the world's worst about it, take your time, enjoy it. If you like doing this kind of stuff, take your time, enjoy what you do. Don't be in a hurry like the TV repair environment I used to be in 40 years ago. You know, we didn't have time to take your time and smell the coffee. You know, we had to get them sets in and we had to get them sets out. That one don't want to come off. You know, so we didn't, if we suspected a component, we just clipped it. Clipped the leads off, bent the legs on the new one together with the old one, and replaced it. Tell you, I learned a lot back then. I'm realizing now, after being out of it so long and learning so much, you know, with other jobs that I do, electronics jobs and stuff, and also watching some of these people on YouTube, that, you know, there's a lot of things that I did not get taught, did not know back in the day. So So this channel really is for two things: just to share my experiences with you guys. Thought maybe somebody might be entertained by it, and maybe show somebody something that could help them. But I also invite discussion. You never stop learning. I guess that's my point. You never stop learning. If you ever say you stop learning, you either are full of yourself or you're dead. You always learn something. And I'm just trying to be particular with this. This stuff is unobtainium. I'm just trying to get it out intact. I don't know why it ain't wanting to come out. But anyway, you always learn things, and I've learned stuff from watching. No, I never said. Let me back up. I get ahead of myself sometimes and forget what I'm saying. It's just I'm OCD. I've got attention deficit disorder. Also, I'm stubborn. I'm very. There we go. Got it. I'm stubborn. I'm very. I'm grouchy sometimes. I got a lot going on for me. But anyway, this capacitor's out finally. Before I test this capacitor, I want to know what its voltage rating is. So, and I don't remember. I think that's a 200 volt. Let's see if I got my chart. Where is my chart? I have a chart. Don't know what I did with it. Hang on. Okay, two things. I was calling these things Black Beauty, but a lot of people call them bumblebees. So I won't call it a bumblebee because I think that's the correct one. Anyway, this band's on here. There we go. There's your first band, second band, third band, fourth band, and then this is your first and second digit. And the number of zeros is the third band. The fourth band here is going to be your tolerance, and then this band here should be. There could be up to 3 bands here. Okay, this one is a red band and nothing else. So that's a red is 2. Your EIA color codes. Okay, so the red band is 2, and then being there's no other bands, that's a 200. So this is a 200 volt capacitor. This is a 2, 2, and orange is 3 zeros. That's in microfarads. So that would make that 22,000 microfarads, or 22,000 picofarads, which if you just move a couple of decimal places over, equals 0.022 microfarad. So this is a 0.022 microfarad capacitor with a 20% tolerance because that band is black. And let's see. And this fourth band, this band here, the fifth band, that's a red, so that's 2, and black, so that would be a 200 volt capacitor. So this is 0.022 microfarad, 20%, 200 volt capacitor. Okay, now that we know what exactly we've got, let's go ahead and calibrate this thing. Okay, I'll tell you what, let me put you in the tripod. Let me put you in the tripod so I can do this a little better. Zoom you in a little bit. There we go. Now I'm going to start over. Turn the machine off. Turn the machine back on. And I'm going to put all other caps, and then we're going to calibrate it. Alright, now we're going to short. Lead resistance. Try again. Out of zero range. What is up with this thing? Try again. If this don't work, I'll use another set of lead. There we go. Now it's calibrated. So we know the value of the capacitor. Get back and go. We know the value of this little capacitor, so we're going to enter it in here. 0.022 microfarad. Oop. 0.022 microfarad. 200 volts. Now it's not a polarity to this. It doesn't matter how you hook it up. Alright, we'll do the capacitor value. 0.0965 microfarad. What do you want to bet this capacitor's leaky? So we press leakage. It is more resistor than it is capacitor. It's reading about 168,000 ohms or 168K. It is a bad capacitor. It is leaky. So, whoa. So this capacitor's leaky. I told you, you see these, run. You take them out, somebody else wants them, you can give them to them, but don't use them. Whoops, sorry about that. Anyway, let me get over here and find a manual on this, and I'll go ahead and figure out what all I need for the capacitors, and bring it back. Okay. If we know this this bumblebee is leaky, and I can guarantee you the other ones are going to be leaky too. So we have 1, 2, 3 .022s. 1, 2, 3 .022s. This one here is a 0.01 microfarad. Another 0.01 microfarad. Then a 0.047 microfarad. That's pretty standard. That's no problem there. Got an electrolytic down here. Not sure of its value. Then you got the main filter cap right there, which I will find which one of these is the primary lead, and then I will we'll try to unhook one of them, and let's see just how bad that is, because I know pretty well that's going to have to be repaired or replaced. Then we'll do some spot checks on these resistors and get us a parts list and get this stuff ordered. And oh, and these little dudes. How can I forget about these? These little capacitors right here. They're ceramic capacitors on the outside as far as the case, but I don't trust these either. Matter of fact, right there I put my finger, it's already starting to separate, which meant the insides are swelling. It's pushing it out. Guarantee you that cap's bad. I'm not taking any chances with these, especially with these little delicate tubes in there. So again, we got 1, 2, 3, 4, 5 bumblebees. 1, 2, 3 of these ceramic capacitors. Let's see, 1, 2, 3. I'm sorry, 6 bumblebees. 3 of these guys. 1 electrolytic, actually electrolytic, and then we got a 4-section can So all of them capacitors is going to get replaced. I'm not going to take a chance. I'll restuff this one. That way it will be completely, other than these capacitors will be yellow instead of black. It will be as close to original as I can make it. So I'll do some spot checks on some resistors. I guess we could do that now. I don't know. Let's see. I decided the best way to do this. We'll just check some. I'm on 20. I'll go to 200,000 ohm scale. We'll check this resistor here, which is a 27K. You know, if I put this in the ohm scale, it'd probably work. That measures 23.5K. That's probably okay. This one measures 34.5. It's supposed to be 100,000. That's because it's got that resistor on there. I can't think that a 100,000 ohm resistor is going to be 37.45K. And I'm going to say it's probably good. Here is a brown, gray, and orange with so that's going to be an 18K resistor. It's measuring 17.6. Here's a 1.5K, measures 1.6. Here is a 68K, measuring 63. I'm okay with that. Here's a 1 meg and a 4.7 meg. Here's 150 right here. That one's showing 0. That's probably in the heater string or something. I don't know. 2.2K. I'm sorry, 3.3K, measuring 3.2. Another 15. I think I might have measured that one already. Yeah, 1.5. Bunch of 10 megs down here. This is a 680. I think that's in the filament circuit. Yeah, because it's measuring across the tube filament. I'm going to call them good. See what this is. Very low value. I'm okay with these resistor values. It just really needs caps. So at this stage, I'm going to, I'm not even going to worry about checking these. I could show y'all how to check a capacitor, but Lord have mercy, y'all ought to know how to do that by now if you're just doing it. It's the same thing I did to this one, I'll do to that one. I'll pull it out, I'll put it on my tester, analyzer, and I'll check it for leakage and value, and if I don't like it, it gets replaced. So the next thing I'm going to do is I want to find out which one of these is the primary filter capacitor. In other words, the first one in the B plus string. I'm going to disconnect the wires off of it, and I'm going to test it, see how good it is, and just to make me feel better when I order replacements for it. Anyway, I'll bring you back. One of these days I'm going to get really high tech and do this like everybody else does. Anyway, here's the part of this power supply schematic for this radio. The line cord right here, the one side goes into the CR1, which is that selenium rectifier, and goes into a R27 130 ohm resistor. Then it's 105 volts after there, and here's the capacitor that I'm looking for. This is that can capacitor, 4-section capacitor right here. This is the capacitor that I want to check. I want to check this one right here, which is called C41A. It appears to be a 60 microfarad. And then it's a 20, and then a 200 microfarad, and then a 40 microfarad. But why is that one 200? I just noticed that. That 200 microfarad. Goes to that guy right there. part of the AGC circuit. That has to be it's part of the the filament circuit, but it's also part of the AGC circuit. So I'm not 100% sure. The reason I know it's AGC because it's connected. See the grid of this tube right here, the IF amplifier here. See it comes the grid, control grid comes out of pin 6, goes through L7 secondary, comes down here. Comes down to this junction right here. That's usually indicative of AGC circuit. Then it ties off and goes all kinds of other places. But here is that where that 200 is right here. Not really sure what that. Well, it's 200 microfarad. But I'm not really worried about that one there. I'm worried about C41A. I just want to know how good or how leaky this capacitor is. Because if this one's good, I might let these go, but I'm fairly sure this capacitor is going to have some severe leakage. And in this set here, I don't want anything leaky, because these one thing I know about these low voltage tubes are they're easy to damage. Anyway, let me get this capacitor unhooked and let me show you that I've actually locked out on that capacitor. It comes right off of that 130 ohm resistor right here, as I said. Let me show you something. This is the section A right here, and there's this yellow wire that comes back around. It's going right over here to this junction right there. So instead of me having to undo the line off of the filter capacitor, I'm just going to undo this lead right here and use it as my test lead. That makes it a whole lot easier. I kind of lucked out on that. So let me pull that lead, which I'm not going to show you all that. That's kind of boring. Let me pull that lead and then we'll get it set up on the analyzer and see exactly what's going on. I'll bring you back. Well, as luck would have it, I lost some video. I was sitting here editing this video, and file number C0026 is corrupted. Basically what it meant was the capacitor, the filter capacitor checked bad. It was extremely leaky, so that was enough for me. So it gets replaced. So I went ahead and made a parts list for everything that I need, and then I'll order it from Mouser probably Monday morning. And I have a feeling once I get all these capacitors in and put the new tube in, and I have to clean it and everything, I think this thing will work fine without doing any adjustments or tuning. I'm going to try not to, and hopefully I can get it cleaned up, and this will be one of my pride and joys in my collection. So anyway, I think it'll be fine. Just going to order, like I said, order a handful of capacitors, change them out, put the new tube in, clean the chassis up, clean the case, and this thing ought to be fantastic. Anyway, thanks for riding along, and hopefully parts come in, I can get them in, and we can have another part 2 before the end for Christmas, hopefully. We'll see. But anyway, thanks for watching. Please hit the like and subscribe button, and I guess I will talk to y'all on the next part. So you guys have a good time, be good, and I'll talk to you later.